Lutz, you are sharing your screen right now. Would you like to say something?
No, it's only for the title picture. I shared the screen.
Thank you so much. That is so kind of you. Well, I would like to welcome all to which I assume or last stars tutorial, Lutz. Am I correct? Or
Uh,
do we have any more tutorial sessions planned?
yeah, we have tutorial sessions in September, quite a lot, and
Oh,
I will say something about it after your presentation, Nihan.
yeah, thank you so much. Well, dear all, I want to thank you, all of you, attending today's STARS tutorial session. I don't know if you attended the previous ones uh, or if it's your first time, but regardless, we are appreciating that you are here today with us. Uh, you might know STARS project is funded by COSME program of European Union, and it aims to support and empower railway SMEs of all sizes and sectors, from uh, tech savvies to traditional SMEs. To provide support for these SMEs, we started to do this tutorial session in which we dive deep in, for example, AI, digital twin, the hot innovative techs that you need to catch on. Today, we will talk about Hydrail, which, as you know, hydrogen is a hot topic right now for everyone in the world. And our tutorial session will be done by Dr. Nihan Aydemir, and without further ado, I would like to give the mic to her.
Thank you very much, Betül, for this introduction. I would like to welcome all of you to our session today. Let me try to first of all share my screen. Share. Can you see all the presentation? Perfect.
Yes, we can.
Right. Right. So today we will talk about the Hydrail. So this is actually the second tutorial on green technologies that we can implement. To implement our simply to our railway industry. Before we start, I would like to give a brief introduction about myself. I graduated from chemistry, and after that, I studied on polymers and nanocomposites, completed my PhD in New Zealand, and worked as an academic as well as a tech director for a long time. So I've been doing both of these roles since the end of my PhD, right? So it's been quite a while. After my PhD, I have been appointed as an assistant professor in Gebze Technical University, Institute of Nanoscience and Nanotechnology. And because I've been also studied and working on commercialization of high-tech ideas, so I have been also appointed as the manager of technology transfer office of Technopark Istanbul. This role has started around 6 months ago. I've been going on in both directions, both in academia and innovation management. So it's quite exciting. And for the continuation, I will turn off my camera because it sometimes makes a little bit problems Right. Wait a second. So I will 24. Exactly. Right. Why hydrogen is important? Because it is a green technology. And as you all know, in European Union, we are trying to achieve zero emission by 2035, or with a more realistic aim by 2050, if you ask me to my opinion. In fact, 22% of all carbon dioxide emissions comes from the transportation, okay? And the highest highest emissions come from short-haul flights, as you see. And then the second one is a medium car that runs on gasoline, and then a medium car runs on the diesel, and then you go with medium haul flights and long haul flights. I would like to take your attention on the fact that if you go short distances with plane, you end up making more carbon emissions, right? And this sort of brings rail transportation, especially the fast ones, extremely important. Because instead of taking a short haul flight, one can take a high-speed train. That's an approach that should be implemented from my point of view. And after that, we have buses, motorcycles, gasoline cars, small ones, 2 passengers, and electrical vehicle. Why electrical vehicles are here? Because obviously we still need to burn fossil fuels to get electricity, and it doesn't end here. This calculation does not include the, unfortunately, the true carbon emission that comes from the battery fabrication. So that is a beast, right? Fabricating a lithium-ion battery is a major problem in terms of carbon emissions. In fact, I remember when I joined to a lecture from a professor from Stanford. They made calculations of the real sort of carbon print of an electrical car, and it was equal to 5 years of a gasoline car. So you start with plus, and based on the sort of, and it was based on the amount of batteries you use to extend your duration. So if your duration is like 200 kilometers, then it is 5 years. If it is 400 kilometers, which is like a standard nowadays, then it goes up to easily 10 years of carbon print of a gasoline car. So that's sad and unfortunate, but it's a reality, right? And then we get trains, right? So the smallest ones are trains. In fact, the smallest one is the Eurostar. It only gives 6 grams of carbon emission, produces carbon emissions of only 6 grams. And also we do have ferries and national rails as well. In fact, despite being the lowest carbon emission provider, the railway industry actually has put a lot of innovation in to lower carbon emissions even more. In the previous lecture, we covered solar power and what was done to actually to go either carbon neutral or even carbon negative, right? So we were even trying to utilize the railway itself to deploy or install some solar panels to produce electricity and feed it into the grid. So that makes us even carbon negative, right? Today's topic will be on, yes, so what were the attempts in general in railway industry that were taken into consideration or even taken into attempts to lower carbon dioxide emissions? One was using either hybrid or electrical engines. Hybrid engines are quite popular in railway industry. It produces extra power from regenerative brake systems, and it is similar to what Toyota has been using in hybrid cars. There are also considerable attempts to decrease the weight of the train by using composite materials. We had covered these two lectures before. We also try to implement solar and wind power at either trains or stations. This is installing LEDs with motion detectors on trains and stations. So this looks like a small step, but it decreased the energy consumption of a train by 37%. Okay, so that's extremely important from a point of view. Operating air conditioning based on occupancy and not temperature. It doesn't only come from, as you see, the carbon emission does not only come from the running of the engine, it also comes from the utilities, right? There have been also attempts to revise railroads to be more linear than curvy. And also people have been working on regulations to alternate development densities to a walking or cycling distance of the rail network. However, we need to be careful in terms of the noise, because if it is a train with a quite busy schedule, then people will be susceptible to more noise, and hence some noise absorption technologies have to be developed to actually absorb the noise coming from the railway and the train. Also, there are extensive research on utilizing AI to decide whether the time or the intensity of the brake and speed and their frequencies. And right, so the electrical or hybrid engines may not be realistic to decrease the carbon emission if the power that generating the thrust of the engine is created from any fossil fuel, right? And in fact, because in Europe, we are abandoning the nuclear power, we have been abandoning it for a long time now. The energy either comes from burning coal, fossil fuels, or solar power, or wind power. If you really want to look at a realistic decrease on the CO2 emission, then we should look into CO2-free energy sources, right? So solar, wind, thermal, obviously, geothermal, and nuclear, and last but not least, hydrogen. So that's the reality, okay? Solar panels, we covered it in the previous class. The amount of the electrical power that's generated from solar energy is not really enough to run the engine of a train. What people can do, or they have been doing, they have been implementing certain devices that converts power to a higher degree. And these devices are extremely expensive because the power difference between the in and out are really high. For, let's say, using solar panel to run your television, you also use a similar device, but it has been studied and developed for a long time, that one. And it is in serial production, and it is cheap, right? So you need a converter, and the converter is expensive. That's the case of the solar power. Same applies to wind and geothermal, maybe, maybe not. Because with the wind and thermal energy, you get geothermal energy, especially with the geothermal energy, you may get higher watts or kilowatts, or even more. Nuclear power, obviously, you need even another converter to decrease it, but we are abandoning it, so that's fine. And we do have hydrogen that we are going to cover in this class. Right, here we go, Hydrail, that's how it looks like. They are generally made in blue, so it's interesting. But the color of the water is blue, so that's why it is. Most of the hydrails are painted in blue, right? And what is Hydrail? It's a generic term. It's not a brand. First, we should clarify that. And it is used for rail vehicles, where the energy is generated from hydrogen fuel. And this energy is used to power either auxiliaries or engines, or both, right? If we want to have a quick look on the history, the first ideation of the Hydrail was in 1998, Dr. Holger Busch. So he had the idea of it during his trip in Germany, where he was traveling with trains, right? So he saw the potential for powering local diesel trains with hydrogen that is used through electrochemical reactions. And he wrote a paper about it, about the ideation, and people were like, yeah, why not, right? And then after that, the first international Hydrail conference was held in 2005, where people started discussing technologies that can actually make a train run by hydrogen. In 2018, after 20 years of the first ideation, Alstom produces the first commercial Hydrail, and Germany starts operation it. Right? By 2022, we saw 30 plus countries that showed interest in Hydrail, either from expression of interest to building factories, right? And Germany and China took the lead on this matter, and they built factories to make Hydrails. And having said that, by 2035, France and some other countries, they actually made solid plans to replace their old diesel trains with Hydrail. In this case, we need to be very careful because Hydrails do not cost cheap. They're extremely expensive, and also the lifespan of a train is high. So this will not be a quick adaptation, especially when we consider that current trains already have less carbon dioxide emission compared to other transportations, right? But that's why the idea is not to replace everything at once, because we already have small carbon dioxide emission. The idea is to replace our diesel trains with the Hydrails when their lifespan is over. So that's why we are looking at 2035. And that's why we are looking at France and some other countries, because certain countries have their diesel engine trains that are sort of newly deployed, so currently deployed, so they may not actually replace them. Okay, so if you look at the first example, that's the first example. So Alstom made it, right, the French company, and Germany started using this as a pilot study, right? So it has a capacity of 300 passengers, and it can go up to 800 kilometers with one tank of hydrogen, okay? After 800 kilometers, the hydrogen tank needs to be filled again, which is fine. The diesel tanks needs to be filled as well. It can reach to a top speed of 140 kilometers per hour. And it's a pilot study, as I said before, because this is an expensive technology, which I will sort of explain further. In Hydrail, so we do have two types of propulsions. One is you obtain by burning hydrogen in a hydrogen internal combustion engine. And the other one, you make a reaction of hydrogen with oxygen in fuel cells, you generate electricity, and you use it to run electrical motors. Okay, so we talk about two different engine types, right? And both of these systems are hybrid. They utilize regenerative braking to lower the amount of hydrogen storage. Why? Because hydrogen storage is dangerous. That needs to be kept in mind all the time. However, there are solutions to make it either less dangerous or to sort of stop being it dangerous. In fact, hydrogen is flammable or even explosive, right? So it's really dangerous to store hydrogen. You have to be very, very careful. And the main cost actually comes from first, the production of the hydrogen, and second is the storage of the hydrogen. So there are two main costs involving the hydrogen production and usage to run engines. And also why, again, hybrid? Another reason is hybrid technology will be with us all the time. Regenerative braking is amazing because whatever the power that you are using, it doesn't matter, right? You can still get some energy back from the brakes and it is good, right? So it's a cool technology, it's developing, and doesn't matter whether we use zero carbon emission or not, it will be in our lives for the rest of our lives probably, because at the end of the day, whatever the fuel, it costs money, and regenerative braking lowers the fuel consumption, no matter the time. If we want to have a look at hydrogen internal combustion engine, we see this engine as you see here. So that's been developed and installed into the Hydrail that Germany used. And if we look at how it works, actually, the hydrogen internal combustion engine itself is very identical to traditional internal combustion, okay? And combustion actually is a chemical process that involves releasing energy from a fuel and air mixture. If we talk about hydrogen combustion, in this case, we have either liquid or gas hydrogen, and we burn it in a modified gas turbine engine, and we generate our thrust. As I said before, it is identical to traditional diesel or gasoline internal combustion, with a one difference that hydrogen replaces the fossil fuel. If we look at that, we see four sort of stages: intake, compression, fuel power, and fuel exhaust. During the intake process, the fuel is mixed with air. In this case, the fuel is hydrogen. It is mixed with air and introduced into the cylinder. In the compression step, the piston compresses the fuel-air mixture to a level, and it is ignited by a spark. And the ignition will lead to combustion, very similar to gasoline or diesel engines. Obviously, the combustion will expand the gases. They will drive the piston, and the piston will rotate the crankshaft. And after that, the rotational motion that we get from the crankshaft will turn the wheels, whether it is an automobile or a train. Obviously, we are talking about advantages and disadvantages of the hydrogen combustion, internal combustion engines. the hydrogen itself has a low ignition energy. That means it can start combustion early. And obviously, we do have a familiar know-how coming from the 100 years of internal combustion engine know-how. You can get a wide range of flammability with changing the ratio of air and hydrogen. And because it has a high auto ignition temperature, you may reach to, by again, arranging the hydrogen and air ratio, you can get higher sort of horsepowers, if you call it, right? Disadvantages, obviously the cost of producing hydrogen. That is the main problem of the hydrogen technology, okay? Same applies to the cost of storing hydrogen. Also, because it is a new technology, we also talk about we need to sort of point out the lack of infrastructure and lack of regulations that will allow us to adopt hydrogen. In terms of lack of infrastructure, first of all, we should note that there has been a lot of research, development, and investment has gone into electrical cars. That is why, from my point of view, we will not see hydrogen cars for a while, because companies made big investments on electrical cars. So that investment required to return. I will give an example from a different technology that explains the lousy sort of efficiency of our computers and the phones, right? So you talk through a phone, it gets hot quite often, quite quickly. It's not only because of the battery charging and discharging, it's also the battery. So it's also, the heat also comes from the processor of the technological devices. Those processors are made from silicon devices, silicon transistors. I made them a lot. And the silicon transistor has a sort of smaller silicon, has a small band gap. It has even a silicon-based solar panel. It has a 33% theoretical limit. It can never, a silicon solar panel can never reach an efficiency more than 33%. So that's pretty low, right? And we do have other semiconductors that can actually reach to 60%, not even theoretical, the practical people made it. So practical efficiencies of 60%. And you will say that, why we are not using them? And I can even name them, right? It's gallium nitrate, gallium arsenide. And you will ask why we are not using them. We are not using them because obviously the money, the investment that was deployed in silicon industry needs another 10 years to make a complete return. I'm not even talking about making profit in here, right? People make investments in technologies and they require time to get return. That is why we will be seeing electrical cars for a long time. At least companies make their returns. And after that, and probably during this period of time, we will develop feasible technologies to produce and store hydrogen. And then after that, we will be able to see hydrogen. And we are looking at minimum, to my opinion, 15 years. Okay, so how also things work is it works through, as I said before, the thrust can be generated through hydrogen fuel cells. Obviously, a fuel cell can be used in a wide range of applications. It can provide power in transportation or industrial, commercial, or residential buildings, or long-term energy storage for the reversible systems. They work like batteries, but they do not run down, or they do not need recharging. They produce electricity and heat as long as the fuel, in this case, hydrogen, is supplied. Obviously, a general fuel cell consists of two electrodes, an anode and a cathode. In this case, anode is the negative electrode and the cathode is the positive electrode, right? And it's a sandwich type device. And there is these two electrodes are divided or separated through a membrane, and they are covered with electrolyte to allow the electron flow. In this hydrogen sort of case, hydrogen is fed into the anode and air is fed to the cathode, air or oxygen. Okay. People usually use air because you don't need to have extremely sort of like pure oxygen. But the idea air has oxygen in it. Anyway, in a hydrogen fuel cell, obviously we do have the catalyst located at the anode, and that catalyst separates hydrogen molecules into the protons and electrons, right? And these electrons go through an external circuit, creating the power of the flow of the electricity. The protons, on the other hand, migrates through the electrolyte to the cathode by passing the membranes. And they unite with the oxygen of the air, and they produce, obviously, water, which goes out, and the heat. Okay, so we do have heat and the proton, but the idea is we generate electricity from the transportation of the electrons. We get some heat as well, so you need to be very careful. It is a beautiful technology. However, you require excessive amount of R&D cost. It will take some time to build an efficient fuel cell. So we have to be sort of like careful while implementing them everywhere, because if it is made badly, the heat generated through it may even sort of like cause some explosions, okay? And durability is another sort of like question, because the target that we are looking at, okay, the realistic operation conditions, a fuel cell should work in terms of making a realistic performance, it should work over 8,000 hours for light duty vehicles, 30,000 hours for heavy duty trucks, and same applies to trains as well. We are looking at 30,000 hours of running a train and 80,000 hours for distributed power systems. That's a quite extensive performance, and a lot of R&D is going on to lower the cost, increase the performance, and enhance the durability of the fuel cells. Also, you have to keep this system reliable and robust enough to work under dynamic and harsh operating conditions. You expect that train to run at -30 Celsius, right? Or -40 Celsius, or +40 Celsius degrees, right? So it will work in a wide range of temperatures. It will work in a wide range of humidity. And we are talking about an electrochemical reaction, which gets affected from heat and humidity a lot. Okay, so a lot of research needs to get into make this device reliable. Obviously, you do not only need to hydrogen. So these reversible fuel cells are the ones that work with hydrogen. Okay, so also we do have direct methanol fuel cells, alkaline fuel cells, phosphoric acid fuel cells, molten carbonate fuel cells, solid oxide fuel cells, or even polymer electrolyte membrane fuel cells. There are a lot of fuel cells that generate power from electrochemical reactions, and reversible fuel cells are the ones that generate from hydrogen, the one that we have been talking about. Having said that, if you can get clean raw material from all of this, okay, so you can still make these fuel cells to generate power. It will be clean, right? But yeah, good luck with making clean phosphoric acid. It's not clean, right? Or molten carbonate. Okay, in terms of advantages, fuel cells have advantages of obviously zero carbon emission. They are efficient. At ambient conditions, they are highly, highly efficient, and they generate high energy density. If you combine those fuel cells with batteries, because you constantly generate electricity, you can actually simply store it in a battery. It's not like hydrogen internal combustion that you just burn the hydrogen and use it immediately. In fuel cell adaptation, you can store some of the energy in batteries. In terms of disadvantage, really high cost, like it doesn't make sense to use it. Requirement of extensive R&D in the working conditions to expand the working conditions of the fuel cell. Lack of, obviously, again, infrastructure and requirement of batteries is another disadvantage. Because fuel cell reaction is not really fast enough. It's not like hydrogen internal combustion engines. So the reaction in here is a little bit slow. That is why you actually have to run it beforehand, and you always need to have some batteries filled up. So that's the pros and cons. in terms of the general idea, the drawbacks, and if we want to sort of be realistic and outline the drawbacks and pitfalls of the technology, first of all, the high cost of the hydrogen production and storage, okay? And then we do have low efficiency if the production is low cost, okay? So that's a problem, right? So if you may lower your cost of production, but then efficiency will decrease in this case. The limited supply of the green hydrogen is another question. How hydrogen is made? It's made by splitting hydrogen, either electrochemical or chemical ways. The requirement of constantly top of the service stations and deposits. So that's the problem with gasoline and diesel as well. I'm not taking this as a drawback. If you ask me my opinion, this is normal. Even you use gasoline or diesel, you actually have to fill it up. That's fine. The problem is we need to replace all the infrastructure, right? We don't have gasoline or diesel storage units in the stations. Now we will have storage units to store and deploy hydrogen. And all the refueling will be different. That's a big change, right? And also we are looking at high energy consumption. Again, and that energy consumption comes from both producing hydrogen and making necessary infrastructures, building necessary infrastructures. Okay. Yeah, there are a lot of, okay. So there are a lot of questions on the whether on the safety of the hydrogen. As a material scientist, I can say that yes, hydrogen is flammable. Yes, it may cause explosions even, but it can be prevented. Okay, and how it can be prevented from a material scientist perspective, a sort of enough sort of like a piece of boron crystal. If it is dropped into the hydrogen storage tank, it will sort of prevent any sort of flammable or explosion within the tank. So that boron can be implemented in the structure of the deposition tank. So the fuel tank can be coated with the boron. So boron is the sort of simply the boron is the also there are questions. Boron is the key material here. Okay, and that sort of ends the slides, and I see that we do have questions. Right, and the first question is, I want to see, right, so.
If you finish your sharing, I can share my slides, and therefore I prepared a slide with the questions.
Okay, beautiful.
That would be
Okay,
fantastic.
so I will stop screen sharing in this case, right? Okay. Okay, wait a second. No, don't pause share. No, stop sharing. Perfect. Right, I stopped sharing it.
Yeah,
Yeah.
just a minute. Can you see my screen?
9.
Oh, yeah, I have to share it, yes.
Yeah, we can share it right now, Lutz.
Okay.
Yeah, all right. So thank you also from my side for your very interesting presentation, Nihan. I collected 2 questions from the chat, which are visible on the slide. And the first one is, what is the technology readiness level of H2 combustion, hydrogen ICE? And what about the efficiencies, fuel cell and hydrogen ICE? That's the first question.
Okay, so that's a very good question. Technological readiness in terms of hydrogen combustion, internal combustion engine, it is pretty ready. The pilots are running all around the Europe. And actually, the boron has been proven to increase the safety of the hydrogen deposition tanks. So it is good. That's the biggest advantage of hydrogen combustion engines. They are the most ready sort of form of the green technologies, right? So it is good to go. The pilots are running, and the orders that were made to Almstom were on the trains that run through H2 ICE, so internal combustion engine. So they all work with the internal combustion engine. Would it be possible to replace H2 tanks inside the passenger area? Right. That is a question. You may use another, from my point of view, you may use another, even a locomotive to store the hydrogen. However, you will transport it again into the combustion engine. As I said before, like at the end of my talk, currently there are extremely promising studies that boron actually increases the safety of using boron increases in the fuel tanks, hydrogen fuel tanks, increases the safety to a really high point. So that's right. So the amount of hydrogen that you need is not really high. You will need to refuel with the current pilot train. Actually, it's not pilot, it's running commercially, so I wouldn't call it pilot, but let's say it's pilot. With the current trains, you do have a range of 800 kilometers, which is, from my point of view, is a pretty good range. And then what you need to do, you need to refill the hydrogen. And if you are scared of filling the hydrogen, you can simply replace the tank. So you do have tanks that are already filled with hydrogen, ready to go. All you need to do is replace the tank. So you don't move hydrogen from one tank to another. You completely move the tank, which is fine. And if you think that removing a tank will be a difficult task, then you can have multiple smaller tanks that can be easily removed. Yes. So, and also the question, you do not want to place hydrogen tanks inside passengers' area. No, there are different solutions to it, as I mentioned previously, like now. Yes, I hope it answers your all questions. And the other one?
Yeah, I think we have these two questions now. I'm not sure if there is another question and from the audience, and if so, I would invite you to open your micro and ask directly.
Any more questions, whether from the chat or if you want to ask it, you can ask it by voice with your mic.
It does not seem the case for the moment, but we still have some time, while you still have some time to answer, to ask some more questions, because at first we are good in time, and second, I have some slides to present on the next STARS activities. And if you agree, Beatrice, I will proceed with my presentation for the moment.
Of course, let's.
Yeah. So as Pitu already mentioned in the chat, there is a new YouTube channel of the STARS project where all or nearly all of the tutorials are uploaded, and there you have the chance to download or to watch the tutorials also afterwards. And thank you, Guido, our Italian colleague, insist me in putting all the links into the chat, which you will see also on the next slide. So to summarize the next activities on the STARS project a bit, we decided to create the next activities, a week, a European week of advanced technologies for railway applications, which is from 6th to 14th of September, and it contains possibilities to meet virtually on our B2B matchmaking platform. You will find the link on the bottom of this slide, and I will tell you something about it later on. Then we have some more STARS tutorials, at least 5, maybe a 6th tutorial came also into the schedule, but it is not finally decided so far. And in that time, that means from the 7th to the 8th of September, we have also our STARS Hack and Match event number 5. Starting with these Hack and Match event number 5, there is for the moment the call for solutions open, and that means tech-savvy SMEs and other solution providers have the possibility to answer one or more of the 12 challenges which are on the screen. Has been defined by traditional SMEs, and you have the possibility to apply for these challenges and say, oh yes, we have some certain approaches to answer this challenge, and you can apply for these challenges until the 1st of September. And if you have a new challenge in connection with the topic of advanced technologies for resilience of the railway supply chain, then it is still possible to define an additional challenge if you want. You are invited to do so, and all your activity is fully free of charge. And it's a service, a supporting service by the STARS project, which is on supporting especially small, medium-sized enterprises in adopting advanced technologies for their processes, product development processes, internal processes, and so on. So I mentioned the tutorials, and we have several tutorials on our schedule. For instance, a tutorial organized by the Fraunhofer Institute in Berlin on AI in safety critical railway applications on validation and homologation point of view. It's on the 6th of September, and all the times are mentioned here, and the slides are Central European summertime. For sure, some of you live in other time zones. Please take this into account. Registration is already open, and you are warmly invited also to register for this tutorial. The next one is on 11th September. It's organized by the Enterprise Europe Network on EU funding opportunities. It's here called EU Funding Compact. The real title is slightly different, but the contents is the same. We will introduce to you some current EU funding opportunities, starting with Cluster 5 of Horizon Europe, with Digital Europe, and maybe we also get some information on the next plans of the Europe's joint undertaking. The registration is open, and you can register also for this tutorial, which is, as all tutorials are, free of charge to attend. Then we had a third tutorial. It's also organized by the Fraunhofer Institute in Berlin. It's on smart sensors and communication technologies for railway applications, and registration is also already possible, and use the chance if you want to know some more information about smart sensors and communication technology. And we have two other tutorials which are not scheduled exactly, but it is on the technology innovation analysis, what the Technology Center from North France called Millennium conducted during the STARS project. They had already performed two tutorials, and part 3 and part 4 will follow on assets for automated, autonomous, or remotely piloted operations and network management, planning and control on the one hand, and on the other hand, regional rail services, innovative railway services to revitalize capillary line and railway multimodal and intermodal transport. Very interesting topics. The dates are somewhere in mid of September, and the registration links will follow soon. In some of the European countries, we have still have some summer holidays, so be a bit patient to receive the registration links, but as soon they are available, we will inform you. So I mentioned the possibility of virtual B2B meetings, and a precondition for this is to register with a short profile on the STARS Hack and Match events platform. And it's also free of charge to be registered. You can register with a small profile. And if you can see here, there is also the so-called marketplace section. And within the marketplace section, you may describe your services or products you are providing. So make your profile a bit more interesting to other participants of this platform. Nowadays, over 70 participants already using this platform, and we will organize some dedicated time slots within the week of the European Week of Advanced Technologies. I already mentioned in September to give you the chance to ask for a virtual one-to-one business meeting, but in general, you could do this every time. So use the link to the STARS Europe B2B matchmaking platform, and then you can see and make use of it for your business, for improving your business. So that is it for me for the moment? Yes, and if there are some other questions, I cannot see some more questions in the chat, but maybe we have some minutes left to give you the opportunity to open your micro and raise your questions.
Thank you so much, Lutz. Well, if we have any questions, like Lutz mentioned, you can directly ask it, or I'm going to share my email address in the chat. You can directly send them to me, and I can forward them to Dr. Aydemir. And let's wait a minute or so to hear if we have any questions. And if not, I really thank you for this tutorial. I really thank you, Lutz, for your always constant support every time.
Normally, normally there is a popular question which is raised anytime is, are the presentations available, and so on and so on. We will prepare a follow-up email to all of the registered people for this tutorial to provide them the link to the YouTube channel of the STARS tutorial. For sure, the video will be available within the next days. And has to be cutted and so on. And for sure, we have to friendly ask Nihan Aydemir for her presentation. And as soon as it is available, I will send you, all of you, this follow-up mail. And for sure, also with the information on the following tutorials and opportunities in the STARS project.
Thank you so much once again, Lutz. Therefore, I don't think we will receive any more questions. I would like to thank all of you for attending and being here, and I would love to see you in future tutorials. We have a great team that they devolve on each and every topic, and I think it would be really beneficial for all of you to attend. Moving on, we only have 1.5 months left within the project, so whichever you can gain, it's a gain. Whatever you can gain, it's a plus for you. Thank you all for attending, and we are ending this tutorial session here. Have a very nice day, and see you all in the next tutorial session.
Yeah, thank you also from my side. Thank you for you, Betul, for the good organization. Thank you, Guido, for the good assistance in the chat. Thank you, all of you, for attending this tutorial.
Okay. So we are ending the meeting. Have a nice day, all of you.